Okay, so in this conservation of energy example, we have work being done by a non-conservative force. In this case, that force is friction. So the problem is a 17-kilogram child descends a slide 3.5 meters high and reaches the bottom with a speed of 2.5 meters per second. How much thermal energy due to friction was generated in this process? And then I added a second part to the question that wasn't in the book. Also, if the slide is a total of 7.0 meters long, what is the average force of friction? Okay, so since we have a changing of height in this example, and they're asking about energy, we're going to use the law of conservation of energy. So we're going to write out work non-conservative plus PE initial plus KE initial equals PE final plus KE final. Okay, now since there is friction working against the child as they slide down the slide, we're going to keep the work non-conservative. The child had potential energy to start with and no kinetic energy because they started from rest. And we're measuring the height from 0 here at the bottom of the slide. At the end, the child has no potential energy because they're at the bottom of the slide at the 0 mark, and they have kinetic energy because they are in motion. So the question really wants to know how much thermal energy. This is not a term we've really seen, but if we think about it, really what it's asking is how much energy was dissipated because of friction and turned into heat. Or another way of saying that is how much work was done by friction in this situation. So we want to know what the work done by friction is, the work non-conservative. So we're going to solve for WNC here. I'm going to subtract PEI from both sides. And I get KE final minus PE initial. So what I can do is do 1/2. The mass is 17 kilograms. And V is 2.5 meters per second squared minus 17 kilograms times G is 9.8 meters per second squared times H, which was 3.5 meters. Okay, so that first term, 0.5 times 17 times 2.5 squared is 53.125. And the second term, 17 times 9.8 times 3.5 is 583.1. So if we subtract those two, 3.125 minus 583.1, I get negative 530 joules. And the reason it's negative is because friction is taking away energy in this case. So the difference in energy between the starting potential and the ending kinetic is the work that was done by friction here. Okay, now in the second part it says if the slide is a total of 7 meters long, what is the average force of friction? Notice that we needed to have the distance in here in order to answer this question because friction is a non-conservative force. So the path that you take to get from one point to another matters, and it's going to change our answer. So if we think about it, we know now that the work done by friction is negative 530 joules, and we know that work in general is FD cosine of theta. So I can say negative 530 joules equals whatever the average force is times the distance, which is 7 meters, cosine of 180 degrees. And I say 180 degrees because it's friction. Friction is going to be opposite in direction to the direction of motion as the kid slides down the hill. So that's where the 180 comes in. Keep in mind cosine of 180 is negative 1, so I can divide both sides by a negative and get rid of that, and divide both sides by 7. So 530 divided by 7 gives me an average friction force of about 75.7 newtons of force. So first I found how much work was done by friction, and then I solved for what was the actual force of friction. We want to be careful that we understand how they are different. One, the work is going to be in joules. That's how much different the two, starting and ending energies were. But the force of friction, again, that's in newtons. And in order to find that, we had to make sure that we divided by the distance traveled, the work by the distance traveled, that is.